Hello Longhorns, I'm making this video to help you with your graphing of trig functions. The one thing I want to point out to you all, everyone seems to be having a little difficulty with the new horizontal axis values along the horizontal axis instead of x values being integers 1, 2, 3, 4. We now are using angle measurements. So this is where there seems to be a lot of confusion between the tables that we're creating and where to graph them on the graph. So before we do that, I want to go back over what's on the unit circle and then what's on a typical trig graph. So the first thing I want to talk about is this, the unit circle right here. You know that this point here is 0 or 2 pi. This is pi over 2. This is pi. And this is 3 pi over 2 if we're going the positive direction. So if we're going in the positive direction, then we're going up from the standard position. So up from the standard position, we'll end up at pi over 2. And then if we keep going, we'll end up at pi. And then 3 pi over 2, and then back to 2 pi. So where does that relate to on our graph? Well, that's these points right here on our graph. And so we have the origin, which is 0, 0. That's this point right here. Then we have pi over 2. That's right here. Here's pi over 2 on our graph. Okay, pi is the next one. Here it is, pi. And then 3 pi over 2. And that's right here. And then the last point we usually use in a cycle will be back to 2 pi, which would be back to the origin. Okay, and usually this is what we call a period. So if we go all the way around the circle once, that's one period. So usually a period is measures how quickly we can create one cycle of our graph, or one up-down movement, or one cycle. So going back the other direction, if we're going back on our graph, if you look backwards here, this says negative pi over 2. Well, we're going backwards to the negative direction. So if we're going to the negative direction here on our unit circle, we're also going to go negative. So if we're going from the standard position in negative direction, then the first angle we hit is going to be this, negative pi over 2. And that's why you see negative pi over 2 here on your graph. So this point right here is negative pi over 2. That corresponds to this angle measurement when we're going in the negative direction. Then we have negative pi, that's this one. And then negative 3 pi over 2, that's this one. Okay? So as you're creating your graph and you're repeating your wave, or your graph repeats, this is what's happening on the graph. So this is the basic thing that you must understand when you're graphing from your table, so you know where to put your curves. Otherwise, we're getting all kinds of crazy designs on our graphs that are not trig functions. So we need to make sure that what we're drawing looks like the graph example that's in our notes. If it doesn't look like the graph example that's in your notes, then you're not graphing it correctly. And we need to take a look again at your graph, your horizontal axis labels, and what values you're using for your angle measurements. All right, let's go to the homework assignment. I'm going to walk you through a couple of these graphs, and I expect you to be able to do all 5 graphs on your own as your homework. And this homework is for my class is due Monday night at midnight. So you had all day Friday to work on it, and then you're going to have Monday also to work on it in the evening. And we're going to be doing something else in class on Monday. So make sure that you're getting these graphs completed. And if you're having any trouble or you have any questions, make sure you bring those to me at the beginning of class and just tell me what it is that you're having trouble with, and we'll go over that before we move on. All right, so here's the homework assignment. I'm not going to do this exact problem because I want you to do it on your own. And you may have already done this one, and that's okay. Just leave it the way it is. I'm just going to use this as an example of how to do this. So in case you have any questions or you are stuck on something, maybe this will help. I am going to change this equation though, so that it's similar but not exactly the same one. Okay, so I've changed it to negative tangent of x over 2 plus 1. And if you know the way we've been graphing x, since we have our angle measurements are along the x-axis, so now our x-axis is an angle measurement, and we often call that angle measurement theta. So you can call it x now, or you can call it theta. So it doesn't really matter in this case. We know that along the x-axis we have angle measurements, and that's what we're going to use. Okay, so the first thing I want to look at is, are we doing anything to the angle? Is there any inside the parenthesis thing that's happening to the angle? Well, yes, there is. We have this x over 2. This is the same thing as 1/2 x, or x divided by 2. So we know that if it's an insider, we need to do the opposite operation. So if we are dividing by 2 here on this x, then what we need to do over here on our table is we need to multiply by 2. We need to do the opposite operation. So we're going to multiply by 2. So we're multiplying all of the angles by 2. Now when you do your graph, it's going to be different because you're going to be multiplying all of your angles by 4. So it'll be a little bit different than what I'm graphing on here, but this is just an example for you to follow. So you can follow this example when you're graphing your graph, but your graph is going to be a little bit different than mine because you're not multiplying by 2, you're multiplying by 4. All right, so I'm going to go through the angles and I'm going to multiply them by 2. When I multiply this negative pi over 2 by 2, I just get negative pi. And when I multiply negative pi over 4 times 2, I get negative pi over 2. And then 0. And then pi over 2. And then pi. So those are going to be my new angle measurements that I'm going to graph. So now what I'm going to do before I even do anything to y value, I'm going to go ahead and mark these places on my horizontal axis so that I know where I'm supposed to graph my points. So I know I'm going to have a point here at negative pi something, negative pi over 2 something, 0 something, pi over 2 something, and pi something. Okay, so I know I'm going to have that. Now your graph is going to be a little different since you're multiplying by 4. Yours is going to be really spread apart, a lot more than mine is. Okay, the next thing we're going to do is check our period. What is happening with the period? So since we're doing tangent, okay, since y is our tangent value, we want to see what the tangent value is for all these angles around our unit circle. Okay, so look back at your unit circle. Remember, negative pi over 2 is has the same angle measurement as 3 pi over 2. So that's down there at the bottom of your circle. So tangent is undefined at that spot. So I'm going to put that in red, undefined, because anywhere tangent is undefined, I'm going to have an asymptote there on my graph. Okay, and then we're going to, again, we're going to keep going down here. Negative pi over 4, the value for tangent at negative pi over 4, that value is negative 1. And then at 0, tangent is 0. And then at pi over 4, tangent is 1. And at pi over 2, tangent is undefined again. Okay, so now we're going to see what values we're going to get with these y transformations. Now the y transformations are all the outsiders. So here we have a negative tangent, and here we have a +1. What this means is that I'm going to take all of my tangent values and I'm going to multiply by a -1, and then I'm going to add 1 to each one of those. So the ones that are outside the parentheses is what happens here in this row. So undefined is undefined. I don't care what you do to undefined. It's still going to be undefined. Okay, we can't do anything with that. There's an asymptote right there. Okay, with the next value, we have -1. Well, -1 times -1 is a +1, and a +1 plus 1 is 2. And now we have 0. 0 times a -1 is 0, plus 1 is 1. 1 times a -1 is a -1, plus 1 is 0. And then we have undefined again. So the two columns that I have starred are the two columns we're going to graph. Well, I already marked my graph with my horizontal values for the angle measurements. Now I just need to put in the y's. Okay, so right here at -pi, I've got an asymptote. I'm going to put that in red. Okay, so the asymptote means that there's a vertical asymptote here that I cannot cross when I'm graphing my tangent. Okay, so tangent won't repeat until after that asymptote. Okay, so the next 2 points I'm going to put in are at -pi/2. I'm going to put in a 2. So at -pi/2, I'm going to put in 2, which is right here on my graph. And then at 0, I'm going to go up 1. Oops, that's not 1. 1's right here. Watch your scaling. And then if I, when I get to the next one, pi/2, I'm going to go up 0. So that's just going to be right here. Okay, so where does my graph go? Well, it's going to come along the asymptote, but not touching it. And then it's going to curve in through these points and then curve back out. And that is your tangent. So the next one is going to be on this side, is going to go like this, back through those same points and back out again. Okay, and it repeats. So tangent has an amplitude of none because tangent doesn't have amplitude. So you could say none or NA. The period for tangent is pi because tangent can only go pi around the circle before we hit an asymptote. So it can only go halfway around the circle before we hit an asymptote. So the normal period for tangent is pi. But in our case, we stretched it out a little bit. So in our case, we multiplied tangent by 2. So now my period is 2 pi. All right, the vertical asymptotes are x equals pi and x equals -pi. So the way I'm going to write that is just, I'm going to simplify it a little bit since I can on this one. You're not always going to be able to do this. Sometimes you have to write two different equations, but I can just do plus or minus pi. Since I didn't have a phase shift, I can do that. And the vertical shift was up 1. So I'm going to put, I could put +1 or up 1. Okay, so the vertical shift was up 1, and you can see that right here, the vertical shift from the center point. So it's up 1 from the origin. And that's it. That's our tangent graph. So if you did all of those things and you answered all of those questions correctly, then you got the first graph correct. And of course, your graph is going to be a little different than this example. Don't forget, you are dividing by 4, which means you're multiplying your angle by 4, and you are multiplying your y value by -1, but you're adding 2. Okay, so that's going to be different. So your graph is going to look a little different than mine, but it's going to be very similar. All right, in this example, I'm going to go a little bit faster, not so much explanation about the angles and such. I'm just going to go through the table, graph the graph, and fill in the amplitude, period, vertical asymptote, etc. Okay, I am going to change this graph a little bit. This is number 5. I'm changing it a little bit, and once I've changed it, then I'll start graphing. You will need to do the graph that's on your paper, though. Don't do the one I'm doing as an example. Okay, let me explain what I did on here. Okay, first of all, I changed the equation so that it's not exactly like yours, but it is similar so that I can explain how to do this. All right, so we have a negative tangent again. Here we don't have any period changes, so that means our period is going to be pi. So that's why this is pi. Amplitude for tangent is always NA. We don't have an amplitude for tangent. Next, we look at what other changes we're doing to the angle here. It looks like we have a phase shift of pi over 4. So we're actually adding pi over 4 to all of our angle measurements. So I went down the angle measurements here and I added 1/4 pi to all of my angle measurements. And I ended up with negative pi over 4, 0, pi over 4, pi over 2, and 3 pi over 4. Then I came over here to my horizontal axis and I put those dots in. This one's at negative pi over 4. This one's at 0, pi over 4, pi over 2, and 3 pi over 4. So instead of having my x-axis broken up into halves, it's now broken up into quarters. So you need to make sure that you put these points in their correct spot. The next thing I did was look to see what kind of changes I had to my y value or my tangent value. So I have a negative sign here, which means I'm multiplying everything by -1, and I'm subtracting 1. So I come over here to my values for tangent, which are undefined, -1, 0, 1, undefined, and I make these changes. So I multiply by -1, I get -1 times -1 is 1, and 1 minus 1 is 0. And then 0 times a -1 is 0, plus a -1 is -1, and then 1 times a -1 is -1, minus 1 is -2, and these are the values that I'm going to graph. So I'm graphing this column, and I've already put the dots where the x values need to be, or the angle values, and so I just need to graph these in. Well, I know undefined is going to be my asymptote, so I put the red line in here as my asymptote. These 3 points here are right here, 0, -1, -2, and then I draw in my tangent line. Now I put in a couple extras just so that you can see that the tangent does repeat on each side of the asymptotes and in between the asymptotes. So in between all of these asymptotes, we get another tangent line. And that's it. Oh, the vertical asymptote for the tangent lines here were negative pi over 4, this one, and 3 pi over 4, this one. So that's where our tangent lines, asymptotes are. And then the vertical shift was down 1 unit on mine. It'll be different for yours. See, this is yours. Yours is different. Okay, and that's it. Good luck on your homework.